Throughout South Africa, low-lying areas, such as this one, becomes a much more dangerous place after a time of heavy rain.
The Orange River burst its banks due to heavy rains at Ograbis. Police have recovered 3 bodies.
Wat ons nou moes gehelp in die noodsituasie.
So we are really aiming at providing people with this information to help them plan their journeys and avoid these risky situations. We at Northern Solutions are developing an open data platform to distribute this critical information. As a civil engineer, I developed several hydraulic models, and these models often require a large amount of investment in terms of time and money to set up and calibrate. Our approach, on the other hand, takes a more data-driven look at the problem, and we developed a machine learning solution to predict downstream flood events based on recorded upstream flow. Fortunately, the Department of Water Affairs collects this data at over 500 locations across our country. So looking at the outputs of one such model, you can see the flood event in the center of the graph here. You can see the predictions of our model in orange and the actual flow in blue. You can see that our model predicts this flood event quite well. So looking at another flood event in 2006, we're looking at the results of an actual hydraulic model that was set up by the Department of Water Affairs over the course of 3 years and at the cost of 3 million rand. So you can see the predicted flows in black and the recorded flows in green, and you can see there's actually quite big discrepancies between the predicted and recorded flows. Looking at the results from our model, you can see there's a much closer correlation between the predicted and recorded flows, and this model was set up at a fraction of the cost and in a fraction of the time of an actual hydraulic model. So the way our machine learning models work is that they use neural networks, and the way these networks are trained is we run historical flow gauging data through the network using upstream flow gauging data as input and then mapping it to downstream flow gauging data as output. And we run many data samples through this network, adjusting these weights and then teaching the model how to map input to output. And that's how we train these models. The specific model was set up as part of my master's thesis that I completed recently. I've been a software developer for 10 years and have been involved in several large-scale software systems for municipalities over that time. I recently started Northern Solutions specifically to take a look at flood risk management and water resources management of our country's rivers. And I'm really excited to partner with companies like Santam to make this a reality.